In this lecture, we are going to explain about the most important and required skills for you to become a hacker. As we said earlier, one of the most important subjects in computer science is networking, that how data travels through different devices until it reaches the destination. As you know, in the real world, when we want to send some data to other person, we need to have the address of the destination, and somehow for example, in order for the other end to know that where this data come from, the mail that we are sending should have a source address as well. There are two types of addresses in computers: MAC addresses and IP addresses. One of them is physical and the other is the digital address. Every packet that moves from one device to other device should have one or both of these kind of addresses. We would talk more deeply about both MAC addresses and IP addresses in the future lectures. Also, you should know the concepts like protocols, ports, and sockets, what they are. For example, when two persons they want to talk to each other or communicate, they should both obey a set of rules. In computer, this set of rules is called the protocols. For example, when you want to browse a website, as you are a client that you want to browse a website, and at the other end is a server. This client and server, both of them should follow a set of rules that we call them a protocol. In this example, this set of rules or this protocol is HTTP. You should know about the important protocol like dhcp or dynamic host configuration protocol, that how when the client connects to a network, how an IP address is assigned to that client, because as we said, in order for every device to be able to send and receive data, he should always have the an IP address assigned to it. This IP address assigning could be a static or dynamic. The DHCP is a dynamic form of assigning IP address to different clients by the administrator of the network. Then we have the R protocol. We said that like the DHCP, that is for the IP address, which are the digital addresses. We see the ARP, which is the address resolution protocol, is somehow the resolution of MAC addresses and IP addresses to each other. Again, we would touch deeply about all of these concepts in the future videos. Then we get to the DNS. You see a lot of times that then we want to browse a website or connect, we just type the name, for example, google.com or YouTube or other things. But we know that computers could only work with the numbers and zeros and ones. This DNS is somehow the resolution of domain names or the names to the IP addresses, or the we could say the alphabetic names to the numeric addresses. And then we have other things like the virtual private network or VPNs. Again, one of the important concepts in the networking. Somehow sometimes you need, for example, to hide your IP, or you need to send the packets to other network, and from that network to the internet. These are VPN. Again, we would go deep in the future videos. We also have the OSI model and TCP IP model. We somehow, in order for us to better understand what is going on in different networks and communications, we somehow create a models for to simulate the behavior of a network or different devices, that how a data is sent to the destination and vice versa, what other things should be completed throughout this process. So we have created two models, OSI model and TCP IP model, which we will explain in details. Then we have the network address translation. Because we are running out of the IPv4 addresses, sometimes the internet service provider assigns just one public IP address which are routable to our network, and then when different clients or devices from inside the network want to connect to the devices outside the network, the router will somehow translate the private and not non-routable IP address of the clients to its own public IP address, which is routable, and then send the data out in the internet. Then we have the VLAN or virtual networks. We also have subnets. Sometimes we need to just divide our networks into different smaller networks, or as we call it, the subnets. Then we get to the network devices like routers, switches, and hubs. All of these network devices are just some switches. The only difference is that some of them are smarter and some are not. For example, hub only reflects the data coming from one port to the other, or to all of the other ports, but routers are more are smarter. What the router does is that it looks at the destination IP address in a packet and then somehow forward it through different hubs until it reaches the destination. So all of these network concepts and many more that we would try to explain in the next lectures are covered in the CompTIA Network Plus. After which you could search or get this degree. Having the CompTIA Network Plus means that you have the basic understanding of different concepts in a network. If you want to go more detailed, you could look for the CCNA, which is a more advanced degree in the networking. After that we have CCNP, CCIE, and so on. These are Cisco degrees. So after that, I just want to explain to you about one application, which is the Wireshark. Wireshark is the most important network analyzer in the computer science. You could just sometimes, for example, you send one packet, you want to send it through the internet or other devices. Using Wireshark, you could know that how this traveling of this packet, how it goes on through the network, analyze different headers in each layer. Using the Wireshark, see the equivalent hexadecimal representation or even the bits and so on. It is a traffic and packet analyzer, which is a very good thing that we will talk about in the next lectures. Also, in the networking, you should have some knowledge about the wireless communication, the RF communications, how signals go through different medium until it reaches a destination. Also, some authentication mechanisms like web WPA and WPA2, which again we will talk about in the next lectures. Also, you should have some knowledge about the cryptography, because sometimes there are a lot of different attacks that some hacker could come in between of the client and the destination. In this way, you should somehow have enough knowledge that even if the hacker has complete access over the data that you are sending to the destination, he wouldn't be able to make sense of the data. What you would do is that you encrypt the data using some mechanism in the cryptography, and when the data gets to the destination, you somehow tell the destination that what is the key, how you could decode and make sense of the data. But because the man in the middle or the hacker doesn't have that key, or how this data has been encrypted, he wouldn't be able to make sense of the data even though he has the complete access over the data. Next, we should have the complete knowledge over the computer architecture. If you want to be a hacker, it is a very important section. You should know what are the computers made of. We know that every electronic device has been made of a component called transistor, which we explain in the next lectures. Also, you should know about the important elements in the computers, memory, CPU, and so on, and how these different components like RAM, CPU, and so on, they connect to each other to complete a task. So after that, we have some knowledge about the networking and computer architecture, and we know what to do. We know how to secure or actually use a security issue to exploit or do any kind of penetration testing. And now we need to tell the computer what to do. Programming languages are for us to communicate with computers and tell them what to do. Well, we know that the machine language, the only way that we could talk to computer is through the using of the machine language, which only understand zeros and ones. But understanding the zeros and ones is a very hard task. So what the computer scientists did is that they invented another higher level language called assembly language. So for example, let's say that we have some data like 100000101. What the assembly language is, well, this data, when it gets to the CPU, for example, it would divide different bits. Every bit has some meaning for the CPU. So let's say that the first 4 bits are for the CPU to understand that this is an instruction to load the data in the second 4 bits into a specific register called B. If you don't know what I'm talking about, these different concepts like register and so on, you would be familiar with in the next lecture. I just want to tell you the relation between assembly language and the machine language. Now, what assembly does is that, well, I know that the first 4 bits means that this is a load B instruction, and the second 4 bits, because I know the binary is 0101 is equivalent to 5 in the decimal, so we could say that this is actually load B5. So when we as a human, when we see load B5, we know that it means that we know the data, we want the data in the memory address of 5 to be saved in a register called B, to be loaded in the register of B. But if we see these 8 bits in here, we would not be so comfortable to make sense of this data. So assembly language is a one-to-one mapping. The only application of the assembly language is just for us human to be more comfortable. After that, so now in the assembly language, well, we know that the machine language is zeros and ones, and computer only understands 0 and 1. But when we write some program and we want to tell computer using this instruction, we somehow should translate these instructions to zeros and ones. There is a software called assembler which has this duty, which converts the assembly language to the machine language. So after that, we have higher layer or higher level programming languages like C, C++, Java, Python, and so on. Sometimes you may see that we in every one of these programming languages, we just, for example, type print 5 or something like that, and we see that computer just print the thing that we want. The printing itself is made of multiple instructions, maybe 50 or 100 different instructions to be completed. If we want to just use them, even using the assembly language, because it is a one-to-one mapping, we should write 100 different instructions, which is a very hard thing to do. So earlier computer scientists, what they did is that somehow they summarized long instructions into smaller ones. So so that in one of these languages we print the task would take place, but in behind the scenes a software has the duty of converting this one command to 100 different instructions that the machine understands. This software is called compiler. So compiler would convert the language, the higher layer or higher level instruction in one of these programming languages to the assembly language, and then the assembler would convert it to zeros and ones. So you could guess how hard it was if we had to just write down every instruction that we wanted. That's why that earlier programmers were actually completely computer scientists, but nowadays you see a lot of different programmers that they don't know what is going on behind the scene. We have a lot of web developers that they don't know much knowledge about different components in computer, how computer works with different data, but they could develop programs. It's all because of the fact that the compilers and assemblers and other softwares have been created to facilitate the programmer's work. But if you want to be a hacker, you should know the complete knowledge that what is behind what is going on behind the scenes. If you want to show you the best programming languages, if you want to be a hacker, for the last section of this lecture, we could say that first of all you should know the assembly language, so that you have a detailed and deep level knowledge over what is going on. we could see in the later videos that there are a lot of different applications that they are not open source. The only way for you to know what is going on is to see the equivalent assembly language of that program. You should also have the C programming language, which is lower level than other languages in here, but is higher than assembly language. If you want to work in the security of websites, you should know the knowledge about JavaScript, which is a client-side language. It executes in the browser at the client side. PHP, which is a server side. Again, if you want to go in the web security, you should have knowledge over JavaScript and PHP. They are completely mandatory if you want to go in that area. After that, you go for the Python, which is a security programming. Actually, they are not in order. I just want to show you the important programming languages. Python may be the most important language for a hacker. If you want to, let's say that using other languages, you have learned a security issue in a program, in an application, maybe in a desktop application or a website or a web application that has been written using C, PHP or other kind of languages. Now you want to automate a task that you think it would exploit that security hole. The best programming language or best tool for you to automate different tasks that you have in your mind is Python. Because as an example, create a socket is just some endpoint for communication and is somehow an IP address and port number. We will talk about it in the next lectures. But creating a socket in, for example, C programming language would take us maybe 100 different commands. But in Python, we could create it using one single command. So Python is easier and stronger than other kind of languages, and as I said, is the best tool for automating different tasks that are harder to accomplish using the lower level programming languages. In the next lecture, we are going to go deeper into each of these sections that we talk in this lecture. See you in the next lecture.